Okay, part three of the pre-lesson. So, got a little water, get a little hydrated, a little Starbucks. I think we're ready to go. All right, so 2 words, amplitude, period. Amplitude, period. If you look at 1-4 day 1 homework, you're going to see find the amplitude, find the period, find the amplitude, find the period. That's our goal. How do you talk the talk? That's another thing. Amplitude, period. Now, there's a couple formulas that I didn't reveal to you last pre-lesson, and here they are. Well, that one I did. Amplitude is the absolute value of A. Period is 2 pi. By the way, what did we say in the last pre-lesson? What was the period of the sine curve? It was 2 pi. That's considered the normal period, okay? 2 pi. That's the normal period. Keep that in your mind. So this does not say 161. This says the absolute value of B. Where's B? It's whatever's connected to X. Whereas A, it's at the beginning. So to be honest with you, just to make your life a little more relaxing, this is really all that you're responsible to understand for 1-4 day 1. Letters C and D is coming up, okay, for day 2, that sort of stuff. So let's go to this guy, the red one, y equals sine of x. One thing you could do, check out desmos.com. And then just so you know, you get to the graphing calculator, and then there's a box where you're going to be able to type in your equation you'd like to see the graph of. You do not need to type in f of x equals or y equals. That is done for you. And so you just type this in, hit enter, you can see where the graph is. But I explained it in detail on the last pre-lesson, but I'm not going to do that now. So check it out. If you're ever questioning any of these graphs, you can just type it into the Desmos and just look at it. And it does have an option where you can do multiple graphs at the same time, just like I'm doing. But I'm doing it, barbarically on the board. So let's check it out. Y equals sine of x. I'm going to stay color-coded. I'm using my red marker for this red graph. We already know that it looks like this. And there. That one I should have went a little higher, but oh well. Notice it goes through the origin like this. Keep that in mind. As you look over here, we got cosine of x coming at you. A real strong characteristic of sine is it goes right through the origin. Just keep that in mind. This is the foundational graph that we're going to build on. So just like y equals x squared looks like this. And if we put a 2 in, that'd be skinnier. If we made it a half, that'd be wider. We got to have like a foundational graph. This is our foundational graph of the sine curve. Keep that in mind. Let me get rid of that. All right, so that red one is that red one. Now, got the purple marker. What's changed? This. What is that? It's my letter A. Now, if you think of it as a formula, you go, okay, I got to take the absolute value of 2 to figure out what happens to this red one. Well, that's simple math. We already know that it's 2. I mean, just look at it. It's right here. It's 2. Well, why do you need the absolute value? Notice the next one has a negative in it. We'll talk about that then, okay? But it's saying, hey, now your amplitude is double. What that means is, you see where this red one is exactly 1 unit above the x-axis and 1 unit below the x-axis? That just means that this 2 is going to double it. So the peak, instead of 1, is going to be a 2. And where it bottoms out, it's just going to go down to -2. These stay the same, because what's twice 0? That's just 0. So it's going to go like this, and then you can kind of get the pattern. This is going to go down to -2. This is going to go up to 2. So this is going to go down and back up, and then here. As you can see, the new amplitude is now 2. It's 2 above the x-axis, but it's also 2 below the x-axis. Now this is going to get messy, and that's the way it is. I hope you can see this is kind of a turquoise or baby blue color, The only thing different between the purple one and the blue one is the negative. Well, if you take all these positive values in here and you make them negative, it's just going to go like that. I'm going to make these dotted. And these negative values are now going to go above because they're going to turn out to be positive, so they're going to go up like this. And then I can just kind of get the gist. And there we have it. That might be a little too low because that's supposed to be -2, but we're not looking for perfection. We're just looking for get the idea. Okay. So what happened though? Well, this blue one, we say it was reflected over the x. How do we talk about this? Well, because the amplitude was doubled, we say it was vertically, remember, vertical means up and down. And what happened to it? It was stretched by a factor of 2. It was doubled. Sounds fancy, but it's not, okay? It was just doubled. All right, what does that negative do? It reflects it over the x-axis. Uh-oh, we got the black one here. For the first time, we have something here. Notice this is a 1, this is a 1, that's a 1. That means the period for all three of these should have been 2 pi. Let's double check that just to make sure it's true. Let's go with this purple one. Let's start here and let's go through one cycle. There it is. From 0 to 2 pi, it goes through a period. How about the red one? Same thing. How about the dotted blue one? Same thing. So you see the period for all three of these, the purple, red, and dotted blue, are all 2 pi. That's because this B is a 1, and our normal period is 2 pi. Okay? What if B is something other than, well, let me back up a minute. What if it's a 1? And I put a 1 in there? Well, what's 2 pi over 1? That's 2 pi. So formula-wise, if I put this one in, or this one in, it doesn't change the period. So all of a sudden, I've got a new letter B other than a 1. It's a 2. So look at, that's a 2. Well, what does that reduce to? Well, 2 over 2 is 1, so I get 1 pi. All right, we got problems. Now, please listen to me. I am connecting this one to the red one. So I'm going to try to get rid of the purple, get rid of the blue, get rid of the blue, get rid of the purple, and I'm going to get rid of it all, even though I probably didn't need to get rid of all of it. What I'm saying is, the only difference between this red one and the black one is this 2. So I'm saying, how does this 2 affect the red graph? Well, we already figured it out. It took the period, the red one has a period of 2 pi, and I'm going to focus on this section right here. So I'm going to ignore this section for a while just so I don't confuse you. You know what? I'm going to do things a little bit different because I got a different way of doing this. I apologize for changing my mind right in the middle of the lesson, but I'm going to do it. So what I'm going to do, and I want you to get in the habit of doing this, I think your brain is going to wrap itself around it a little bit better, is this. See, instead of going from 0 to 2 pi, I'm going to go from, oh boy, I really erased a lot. That's negative pi over 2. This is pi, that's pi over 2. How much time do I have? Oh, we're good. Okay, so now we've got this situation, and what happens is the black one, because B is 2, we put it in the formula, it cut the period in half, so now we have a 1 pi. So somehow I need to have this thing go through it in half the time, one cycle in half the time. So I'm choosing to go from negative pi to pi. And I'm going to erase this side, and I'm going to erase this side, and now I know what to do. I call this the Star Wars trash compactor scene where the trash compactor is squeezing all those characters, and they have a little beast in the water with all the trash. This is squeezing in because the period is being cut in half. Think about that. So now, from here to here is 2 pi. I need it to be 1 pi. Now I'm going to get my black marker because that's what color this is. So what I need to do is I need to think, okay, from here, see that pi over 2, negative pi over 2? If I look at that, that right there is pi. That's the period of pi. I need to take this red graph, think of it as a, can't think of the name, you know, that musical thing where you go in and out and out. We're pushing it in right now. So this wall comes into here. This dot right here just moved here. This dot moved here. The amplitude is still the same because it's a 1. But now I need to go, see this goes down and up. It's going to do it faster. So it goes down and up. This goes up and down, but I need to do that from here to here. So it goes up and down. So this is different. When the period changed, this is called a horizontal shrink by a factor of 2 or 1/2. This person is thinking divide by 2. This person's thinking multiply by 1/2. But regardless, the period went from 2 pi, right here, to pi. So it's horizontally shrunk. Got that? Now, I've only got about 4 minutes. I need to jump over here. Now, check it out on Desmos. Just type in cosine. Don't take my word for it. But remember I said sine goes right through the origin? Cosine goes over the origin. It's like a bell. Okay? So cosine. See, it makes a big O. Think of it that way maybe. But then it goes down here and here. And it goes here. It goes down here, here, and here. Notice this is a 1. What's that telling me? It tells me the amplitude is 1. This is a 1. You know what that's telling me? My period is 2 pi over 1, which is 2 pi. Well, let's check it. I'm going to go from negative pi to pi. Look, it goes up, then it goes down. And then it would continue doing that, but this is a period from negative pi to pi. It does the same from here to here. It makes a bowl, if you want, or a vase, like that, okay? But I'm taking from negative pi to pi, and I know that my period is 2 pi, because it didn't change. Now, I've got a few seconds left. Yes, I do. Let's look at, I'm going to get a different colored marker, and let's go y equals cosine of, let's go 1/2 x. Okay, what happens here? Well, my amplitude is going to stay the same. It's still going to be 1, so that's good. But this is my letter B. I got to put it in the formula, 1/2. Now, what happens when you divide by a fraction? Isn't it the same thing as 2 pi? I got to flip that and multiply, so it goes 4 pi. Uh-oh. Here's what happens. I know this is tricky, but it's going to take some practice. I'm going to go, stick with my plan. I'm going to go from negative pi to pi, and I'm going to erase the rest of this. See that right there? There's my 1 period. It's telling me, okay, take that same drawing and make it, see, from here to here is a total of 2 pi. I need this drawing to take place in 4 pi. So I need this dot to go up to 2 pi, this dot to go up to negative 2 pi, because what is it now between here and here? Negative 2 pi and positive 2 pi, that's 4 pi. But I need to draw this drawing in this distance. So it's going to go up, and it's going to go down. So what just happened? That right there was a horizontal stretch. By what? Well, it stretched it by 2. I know B is 1/2, but think about it. It went from 2 pi to 4 pi. It stretched it by a factor of 2. Now, with that being said, amplitude is 1. Period of this one is 2 pi. Period of this one is 4 pi. So we're really talking about period and amplitude, period and amplitude. And that ends